Welcome to the second part of the Beginner's Guide to Python. So the next subject that we want to talk about is something called operators, and there are various types of operators, and the first one we're going to start with is arithmetic operators. So I'm going to open a new window, a new file, and we'll save it and call it arithmetic operators. So what do we mean by an arithmetic operator? So essentially it's the same as mathematics. So imagine I have a variable called a and I have a variable called b. If I want to add the two numbers together, I can type result equals a plus b, and then I can print result, remembering to put the str because it turns it into a string. So in this case this will do 5 plus 5, and you can see that comes up with 10. Similarly, we can use the minus symbol, and what that will do is take b away from a. So in this case the answer should be 0, which it is. Now the tricky bit comes when you want to do multiplication. You might think that you have to do a x b, but this isn't the case. The x is just a character, it's not used as the multiplication symbol. The multiplication symbol is actually this one, and this is common for most programming languages. So in this case result equals a multiplied by b, so in this case you should get 25, which you do. And finally we've got division. Now division, again, there's no divide symbol on the keyboard, so the symbol we use is actually the /. So in this case this would be result is a divided by b, which should give you 1. And you can see it's printed out as a real number as opposed to an integer. Now if we wanted an integer, what we can do is we can cast it like this. And as you can see before, where if you want to convert something to a string, you put it in brackets with string. If you want to convert it to an int, then you put the sum within a set of brackets for int. Now, as previously mentioned, there is also the mod. What this will do is it divides one number by another number and it prints out the remainder. So in this case 5 divided 5 is 1, there's no remainder, so it should print 0, which it does. But if I change this number to 8 for instance, you can see we have a remainder of 3, because 8 divided 5 is 1, remainder 3. If you want to do something to the power of something, so for instance if you want 8 squared, what you do is you use the asterisks twice, and what that does is 8 times 8, because 8 to the power of 2 is 64, so we should get 64 if we run this, and we do. And if we want to cube it, we change that to a 3, and you can see that is the answer there. Now another type of operator is the comparison operator. So if we open up a new file and we'll save it as comparison operators. Now a comparison operator is something you've seen in the if statements that we're using. So for instance, if I say a equals 5 and b equals 10, I can say if a is smaller than b, print a is smaller than b, and this here is called a comparison operator. So what comparison operators do we have? We have this one here, and that means less than. And so what we really mean is the number to the left of this smaller than the number to the right? And the way to look at it is the arrow is pointing the large bits to the right and the small bits to the left. So is this number smaller than this number? We can also use the greater than. So I could say, is B greater than A? The next one is equal to. Now to do equal to, we do two equal symbols. And I'll come on to that later on because that's part of the operators thing. But essentially, if you want to compare two things, you have to use the equals, the double equal sign. And similarly, if you want to say if B doesn't equal A, you can use an exclamation mark equals. So that is not equal to. Now we can combine some of these things together. So we can say and what that means is B less than or is it equal to A? So in this case it won't print it, but if we had it as 5 it would, because it's equal to A, and if it's 4 it would print it because it's less than A. And similarly we can do greater or equal to, and that works the same way. So the next type of operator is called a logical operator. So we're going to create a new file and we're going to save it. I'm going to call it logical operators. So a logical operator, what we've seen thus far with our if statements is they've been one thing. So I can set A equal my age equals 50, and I said if my age is greater than 18, print you are to vote. And if I run this, you can see it says you are eligible to vote. But the thing is, in Scotland you can be 16 and eligible to vote. So what we could say is you could do this, and then you could say, elif greater than 16, and where from is equal to Scotland. So what this will do is saying if my age is greater than 18 you're eligible to vote. Else if my age is greater than 16 and this is your logical operator, where from is equal to Scotland, you are eligible to vote. So I can run this and it says you are eligible to vote. So if I now change this to 17, you are still eligible to vote. But if I change this to England, you can see it prints nothing, which is correct because you're not eligible to vote either way. Now you can also use OR as a logical operator. So we could convert all this into one statement. We can say if my age is greater than 18, or, and we use brackets here, my age is greater than 16 and where from is equal to Scotland. This is now all one statement, and we've got a new operator OR, and we've got this operator here and we'll run this. And you can see it didn't do anything. But if I change this to Scotland, I'm now eligible to vote again. Let's look at assignment operators. So I'm going to create a new file and we're going to save it as now. Thus far we've been using assignment operators and you probably don't even know you're doing it. So if I say my name equals Gary, then this equals here is called an assignment operator because you're setting something to my name. And the reason when you're doing an if statement you have to use the double equals the reason you have to use the double equals is because if I've changed that to equals, what I'm actually doing is I'm setting the value of my name to be Gary. I'm not comparing it, I'm actually setting it. So I could set this to Tom like this and run it, and you can see it says invalid syntax. Maybe you meant equals or colon equals instead of equals. So if I use colon equals, it's going to say hello Gary, even though I'm saying if my name equals Tom, and it's not equal to Tom. That's why the double equals is important. So the double equals is comparing my name to Tom. And you can see it didn't print anything. But if I change this to Tom, it says hello Tom. So that is one form of an assignment operator. Now in a previous example you saw me do something like this. So imagine it's my birthday. I want to increase my age by 1. So you saw me do that, and that's perfectly valid. And if I print my age now, you can see it prints 51, and that's perfectly valid. But there's a better way of doing that assignment. And what we can do is that. And what we're saying is take my age and then add 1 to my age, and it will do the same thing. And you can see you get the same result out. And so it's a quicker way of saying my age equals my age plus 1. So you can also use minus equals. So I could do minus equals 1, and in my dreams when my birthday comes it would actually go down by 1, but it doesn't. But you can see here it now displays the number 49 as well. And does it work for all operators? Yes, it does. as shown there. Now, I mentioned previously that operators have to form precedence, and before we finish the assignment operator, let's have a look at that in action. It's the same as it is in maths. So for instance, if I have a variable and I'll call it A, and I'll set it to 50, and I'll set B equals to 10. So if I say result equals A plus B and then print result, we know that that's going to come up with 60, which is correct. So let's now add another variable called C. What do you think the result's going to be? If you think it's going to be 120, put your hands up. Or if you think it's going to be 70, put your hands up. And it is of course 70, because the mathematical order of precedence is multiplication comes before addition and subtraction. Now, what you should do is get used to using brackets in your code. So if you really want to make it easy to read that the multiplication happens first, put it in brackets. Then you know everything within the brackets comes first, and then it does the bit outside the brackets. And you should do that with all sorts of assignments to variables. So the next stage is about input and output. So everything we've done thus far has been within the programming window. So I'm going to create a new file and we're going to save it as input output. Now everything we've done thus far, as I said, is been in the browser window. So for instance, we've done hello world, and that is part of the output, and if we run that, it will work as shown here. And we can set variables, so we can put like that, and that will print hello world and then hello Gary. But it would be more interesting if it actually took in an input from a user, and to do that we use something called the input command. So as an example, we can say, we can take that out of there like this. We'll take all of it out and we'll say my name, in fact it would be better to be your name, and we type in input, what is your name, and then we can put print hello your name. So when this runs, it's going to ask you to enter your name. Well, it's actually going to just display this text here, and it's better to have a question mark at the end because it's a question. And then once you've entered your name, it's going to say hello and what your name is. So what is your name? And you can see it says hello Gary. You've seen previously that the print statement does everything as a string, and the input does it as well. So if I want to collect your age, for instance, I can say your age equals input like that. And if I do print your age is, do you think that will work or not? Actually, if you said yes, then you'd be right. And the reason is, when you input the text it's a string. So when you try and output again, it's still a string. The trouble is, if you want to then add to it, so if I say, then that will fail. So we have seen previously that when you use the print statement, it always prints out strings. And you can see that your age we haven't had to put within str because the input has taken the value in as a string. So this is good in the sense that if I run this module, you can see I can enter my name, I can enter my age, and it will print out the statement okay. If I want to do any sort of maths against the inputted answer, I then have to convert it to something else. For instance, let's do a small calculator. So we'll say A equals input like that, and B equals input and then I'll say result equals A plus B and print the result is like that. Now I'm going to clear this out of here because we don't need it anymore. And this is a very simple addition calculator. You enter one number, another number, and the result should be one plus the other. What do you think will happen here? So we'll put in 5 and we'll put in 6. And if you think the number is going to be 11, you're wrong. It's actually going to be 56. And the reason for that is that both of these have been input as strings. If we want it to be a number, we have to convert the input to be a number. So we put the int around the outside like that. And now you get the result is 11. Now, previously, you've heard me say that the print statement always prints out strings, so you have to convert the number to a string to print it out. But you'll see here that if I do print A, it is actually going to work. So if I run this now and type 5 and 6, you get the result is 11. You see A is printed out as 5, but I haven't converted it. And what I've said previously wasn't 100% correct. The reason you have to convert is that as soon as you start printing as a string, the rest of it has to be a string. You can't mix your variable types up in the print statement. So I can print A like this, and I can print B like this, and I can even do print A plus B. Like that. What I can't do is this. Because you are trying to concatenate two strings together and it doesn't work. So what you can do is you can do a print statement and have each parameter displayed via commas like this. So you can print A, comma, and then the value of A, B, colon, value of B, result, value of result. And this actually works, and you don't have to convert the values to a string. And you can see A, B, result like that. And if you want it to be in all one sentence like this, you can use the F, and then you can say A plus B equals like that. And what this is going to do is going to replace anything in the curly brackets with the value of the variable, so a, b, and then result. Like that. So there are various ways to do print statements within Python. Now all this is well and good, but if we take our calculator, and let's get rid of some of this stuff now because some of it's not right. So if I run this, it will work. Type 5, type 6, and you get 5 plus 6 equals 11. Simple calculator, perfectly fine. But what if I run it again and I put an F and oh, you get an error because F isn't an integer and we're trying to convert the input to an integer, so that doesn't work. So what can we do instead? Well, you can add basic error handling, and to do this what we do is we use something called try, and remember it's Python, so we'll come to this later, but everything requires indentation. And do except like that. Like so. Now if we want it again, put an F in, you can see it says please enter numbers. And that is all we're going to cover from input output in this guide. Now we know we have the input statement, we can make our loops a little bit more interesting than they were before. So what we're going to do is we're going to create a new program and we're going to save it. Extended loops. Right, and the first thing we're going to do is we're going to ask for create a random number. So we're going to do something called import random. Now the import command means it's going to pull in another library from elsewhere, and random's a library built into Python that you can use to randomize numbers. And we're going to get a random number. And all we have to do is type random .randint, and you see it gives you all the possible options. So we're going to say randint, and we're going to open the brackets, and you put the numbers that you want included in the random. So we're going to put 1 and 100. So that will give me a number between 1 and 100. And what we're going to say is we're going to have a value called guess correct. We're going to set it to false. And we're going to create a little game. And what we're going to do is while guessed correct is equal to false, we're going to ask an input from the user. Well, what we're going to say is like that. And what we're also going to say is if is smaller than random, we're going to print too low. Elif guess is greater than random, print too high. Else if it's not lower and it's not higher, it must be equal. Therefore we can say and we can put guessed correct equals true, like that. And this gives us a little game that we can play now. So let's try it out. So I type 50, and of course I forgot to convert my input. So here we need to turn this into an integer, and we'll try again. Too high, so we'll go 25. Too low, we'll go 37. Too high, we'll go 32. Too low, 34. And well done. And you can see I've made another mistake here, because that should be true, and you can see it changes colour. So we'll run it again. And you can see it says well done, and we're back at the cursor. Now let's look at this, and we've got this variable here, guess correct equals false, and we got guess correct equals, while guess correct equals false, and we've got this line here. And all these lines are completely unnecessary, because we could just use the break command. So what we're going to do instead, while true, and that's going to run this loop all the time, because it means whilst true, and it's true is always true, so therefore it's always going to run. So we don't need this anymore. Instead what we're going to use is break, and that breaks you out of any loop. So if I run this now, it's still going to work the same way as it did before. And you see that works. So what the break does is, whatever loop you're in, it's going to break the loop. So you're going to be outside the loop again. And so if I carried on down here, I could just you see you played a good game is displayed, and that's outside the loop. Now let's have a look at the continue statement. So we're going to save this one as continue. Imagine now we were going to do a game called FizzBuzz, and the rules of FizzBuzz are as follows. If the number is divisible by 3, you print 3. If divisible by 5, you print fizz. And if 5 is buzz. And if divisible by 3 and 5, print fizz buzz. So the first thing you're going to do is you're going to say let's say value equals int I plus 1. That means value is always going to be an integer, and it's always going to be between 1 and 100. Okay, and then what we're going to say is you want to start off with this one, because if it's divisible by 3 and 5, you then don't need to check the rest. So what you could do is and what you could also do is and I think that will work. Obviously, the thing we're not showing here is which numbers are fizz and which ones are buzz. And we probably want an else. Like that. And if we go through the list, does it work? Fizz, buzz. Oh, that's a mistake. We forgot to add the noughts in. We need to compare it against 0. So if there's no remainder, you want to print fizz, buzz. If there's no remainder, you want to print fizz, etc. And if we check it now, 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, fizz, and then you get to 15, fizz, buzz. So that works, everything's working correctly. Now what we could do is simplify this and continue. Like that. So what this is saying is, if the value isn't divisible by 3 and it's not divisible by 5, i.e. there's a remainder when you try and do the division, it's just going to print the value, and the continue goes out of the loop and does the next loop along. So instead of going through these statements here, it just goes up to here, and we can prove that point because if we go here, we can say so when you get a fizz or a buzz or a fizz buzz, it should print this statement. But up here, it's not going to do that for anyone that's not there, because it's going to continue around and it's going to skip everything from there downwards. So whenever it's not divisible by 3 or 5, it's just going to exit the loop onto the next number around. So let's show this as an example. So 1, first time round is 1, make that 1. And then we come here, if is 1 divide 3, does it leave a remainder? Yes, it does. And does value divide 5 leave a remainder? Yes, it does. So we're going to print the value and then we're going to continue. So it's going to say it's not going to do any of this, so you're not going to get any of that, so it's going to move to the next number along. So the next number is 1, we add 1 to it, make 2, and it's going to come in here. Is 2 divisible by 3, does it leave a remainder? Yes, it does. Does 2 divided by 5 leave a remainder? Yes, it does. So we're going to print the value and we're not going to go down here. Then we get down to 3 and it's going to go here. It says, is it divisible by 3? Yes, it is. And then you can go down here and you can see that 3 is divisible by 3, but it's not divisible by 5, so it's going to go down here, print fizz. So we don't need all these else ifs if we do it in this fashion. So let's run it as it is at the moment just to prove it works. And you see 1, 2, fizz 3, at least 1 fizz buzz, 4, buzz 5, at least 1 fizz buzz. You can see it's printing out that last statement. So we can simplify all of this. We could say continue here, then we make this an if. And we can take this line off. And what this is going to do is, it means you don't have to have the else ifs if you don't want to. And the whole point of a continue is you might have a block of code where you'd have to run 100 lines of code or do something else, and that something else is one line of code. So the best thing is to put the thing that you do least at the top, and if it meets that condition, you continue out of the loop. But this works. And you can see that works exactly the same as before. And that's how you use breaks and continues within for loops. That is the end of part 2. Stay tuned for part 3 of A Beginner's Guide to Python.